Hey everyone, today we're going to look at the weather coder questions that pop up on the NAV exams. Someone sent me this asking for some guidance, saying that they think that they're interpreting the weather coder book correctly, but they get the answer wrong. So I'm going to go over it real quick. Here's an example problem. And if you know how to read and use the weather coder book, you shouldn't be getting any of these wrong. So I'm going to go over this one. Let's see. At 1200 Zulu time on 31 August, your position is 4314 south, 17544 east. You're preparing the weather coder form. How should you encode the first three groups after the call sign? So if you go to the weather coder book, after the call sign we see our time of observation and our day of the month for that observation. And it looks like this. So if I'm looking at this, I see YY is day of the month. And if you read this, it's in UTC. The reason it's important to know that it's in UTC is you have to apply your longitude or your zone description to your zone time to find UTC. If it's over 12 hours, it can sometimes change the day back or forward, so depending on your time. So day of the month is YY, so our first two numbers are the day of the month, and our second two numbers are our observation to the nearest whole hour. Again, the time should be observed in the nearest whole hour in UTC. And here it gives you examples. So your 12 Zulu observation transmitted at 11:29 will go to 11. That's how you round and things like that. So let's start with that. So our actual time of observation and our day of the month. We're at 31 August, so that's our current day of the month, but we need to apply our zone description. To do that, we divide our longitude by 15, so 175 degrees. 44 minutes divided by 15 gives us a zone description of -12. So our ZD is -12. Our zone time is 1200. That'll give us a UTC of 0000. We did not change the day because we're still on the 31st. That'll stay the 31st. Now, if this was 11:59 Zulu time, would we change day? Still no, right? Because we have to round up as per our first observation of the hour, which is to the nearest whole hour. So 31 UTC 00. All right. So we're looking for on this GG, which is the hour to the, or excuse me, the observation at the nearest whole hour, and YY, which is the day of the month. So we have 3100. And you can see that in answer choice A. Now, if it were me, I would be done with this problem. Why? Because all these answers are different. If you execute the first observation correctly, you won't have to necessarily do the other ones, but we will in this case. Our second is our latitude. So if you go to the latitude, we see 99, latitude, latitude, latitude. Now, if you go down, it says you always encode your latitude with 3 digits. The first 2 digits are the actual degrees. The last digit is for tenths of a degree. So you would code 46 degrees, 41 minutes as 466. Why? Because 46 is coded, the first 2 digits, as an actual degree, and 41 is your minutes, and you divide that by 6. So we'll do that with the latitude that they gave us. So we need to change 43 degrees, 14 minutes to 3 numbers. They said take the first 2 whole numbers of the degree. So 43, and then what? They said we need to divide our minutes by 6. So 14 divided by 6, we get 2.33. But we are only using it to the whole, the nearest whole number. So 43, 2.33 rounded down is 432. So if we look back at our latitude page in the weather coder book, it's 99, and then our latitude displayed in 3 numbers. So we'll do that now. 99432. Go to answer choice A, which is consistent with our first finding 31003, and then 99432. We'll follow the last line and look at the longitude. So we have Q, longitude, 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 longitude. So what is our Q? It's our quadrant of the globe. If we're in the northwest, it's a 7. If we're in the northeast, it's 1. Southwest, 5. Southeast, 3. So that's the first letter. It defines what quadrant we're in right here. We'll go back to the problem. We're in the southeast. We look at the coder. We're in the southeast. So the first number is going to be 3. 3. That's consistent with the answer choice, so we know we're on the right track. We'll now go to the longitude page in the weather coder book. And let's see. You always code the longitude with 4 digits, with the leading figure coded as 0 or 1. The first 3 digits are actual degrees. The last digits for tenths of a degree is coded as, so 142 degrees 55 as 1429. 142 degrees is coded, the first 3 digits. 55 is divided by 6 to get 9. So that's the same rule as the latitude. So we'll do that with our longitude here. So 175.44 is our longitude. 175 is our longitude in degrees, so we'll keep that. 175, and we'll do the same thing we did with the latitude. 44 divided by 6, so 44 minutes divided by 6 gives us 7.33. So 175.7.33, we round down, so 1757. So this is going to be our third, 31757, 31757, 99432, 99432, and then 31003. This is how you use the weather coder book, and I'll do another example for those that need it. These problems like these are hard to prepare for because a lot of us don't have the weather coder book, or I didn't have the weather coder book available, but you can find it online. So you can practice questions like these. There are many out there, but the book is available to you in the test, and I would just use it the day of, and the directions are given. So this should be something that you can figure out on that day. But good luck, and that's how you do the weather coder.